this section we will spend the rest of the week on looking at substitution rule. We've seen a lot of our problems we're not able to easily integrate. You know, we don't have a rule for the product rule in reverse or the quotient rule in reverse. So I keep telling you, you have to multiply everything out or divide everything out and simplify as much as you can before you do the antiderivative. But sometimes that's just not practical. You know, if I said something like, let's say I gave you 3x squared times x cubed plus 5 to the 10th. Before you could do the antiderivative, you would have to do x cubed plus 5 to the 10th power and then distribute. And that would take forever. So it's not practical to always simplify first, and we need other ways to do that. So that's where the substitution rule comes in. Now it doesn't work on every problem, so we kind of have to be able to look at our problem and identify when this is an option. It tells us that if you have a differentiable function, g of x, then if you are dealing with a composition of functions, so f composed with g, in order to be able to do the antiderivative, it also has to be multiplied by the derivative of the inside, because that's like the chain rule in reverse. So easiest is just to jump in and start looking at problems. Okay, this one, we could do the antiderivative on our own because we don't have multiple x's together, right? We've done chain rule in reverse. What substitution says is you can make a substitution in this problem. So the inside function is my 2x plus 1. Okay, so I could call that u. What is the derivative of u? What? Derivative of 2x plus 1 is 2, and then if we're doing implicit differentiation, that would get the dx with it. So if I look at my problem, we have the integral. 2x plus 1 is going to get replaced with 2x plus 1 is u, and that was to the 5th power. And 2 dx is going to switch to du. Okay, so we looked at our problem. We had to identify the inside function. And all of our x's have to get switched to u's somehow. So we made our u the 2x plus 1, so that took care of this. And when we did the derivative of our u, it was all of that, so that became my du. You guys understand what we've done here? Can you do the antiderivative of u to the 5th du? Add 1 to your power, reciprocal in front, the integral and the du go away at the same time. And then the original problem, the original problem though was in terms of x's, so at the very end you have to replace your u. And what is u equal to? 2x plus 1. Okay, this is a problem I could have done without substitution. And if you did, that's fine. But we're going to be looking at some where this is our only option. So that's why I kind of started with an easier one. Did I lose anybody on that example? Okay, let's look at another. Is this a problem that I could just multiply out and simplify? Can you do the square root of 1 plus x squared? No. Can you bring the x into that square root? No. So could I do the antiderivative as it's written as a product? No. We have to try a substitution. When I look at this, my u is the inside function. What's the inside? If you're going to plug in an x, what's the first thing you're going to do? X squared, or 1 plus x squared.
So the square root doesn't matter.
Right.
So whether it's like to the third, cube root, or anything, it's just.
Yeah, we're just looking at the inside part. So this is my u. Now, the du. Du doesn't come from the original integral. Du just means the derivative of the u I wrote down. Derivative of 1 is 0, plus derivative of x squared is 2x. And what would I have to put at the end here? Dx. Because we're doing the derivative, but we're doing it implicit. So when we do the derivative of an x, it gets the dx. All right. So now my goal is to be able to go back to my original problem and write it without any x's. I had a square root of 1 plus x squared. What will that become? Square root of u. Or could I write it as u to the 1/2? And I have 2x dx, but 2x dx is equal to du. Now this is a much simpler problem that we can do the antiderivative of. Antiderivative, we add 1 to the power, so 1/2 plus 1, 3/2. We put the reciprocal in front, so that would be 2/3 plus c. And then at the end, we originally started with x's, so we need to end with x's. What is u equal to? If they're indefinite, yeah. If I had limits, if I had the integral from 1 to 4, then you would get a number. And we'll do more of those tomorrow. Today I'm just doing a few, and all of these are going to be indefinite. All right. Questions on that one? Look at them up. Is this a problem that I could just jump in and do an antiderivative? No, because it's a product, we can't do product rule in reverse. So we have to first identify the u. U is your inside function. Think about it. If I'm plugging in x, where do we begin? What's the inside? X cubed plus 9. When I say inside, most of the time it's going to be like something to a power or under a radical. It might be a trig function, and this is the argument, or a fraction, and it's the denominator. It's kind of like that. The du. When I'm finding du, I'm not looking at this original problem. I'm just doing the derivative of my u. What is the derivative of x cubed plus 9? 3x squared dx. Okay, so now we have to rewrite our integral without any x's. So when I had the square root of x cubed plus 9, x cubed plus 9 is going to turn into u. So that's the square root of u, or u to the 1/2. Okay, what I have left is x squared dx. That's only part of this, because is my 3 up here? So if I wanted to rewrite this and get the x squared dx by itself, what would I have to do with my 3? Divide it over. So I'm going to write that as 1/3 du equals the x squared dx. So the x squared and the dx together get changed to a 1/3 du. And you can write that 1/3 at the beginning. That's probably more standard. I'm just writing it together so you can see how I plugged it in. Did I lose anybody on that step? Can we do the antiderivative? Now this is the same as if I said 1/3 u to the 1/2 du. Coefficients just stay, add 1 to the power, so that would be 3/2. So multiplied by the reciprocal, so 2/3 times the 1/3 that's already there would be 2/9. Are we done? So final answer, we get rid of the u. What was u? I'd like to do 2 or 3 more and then we'll stop with this for today. What would I make my u on this one? And this is a problem, since there is only one x, you technically wouldn't have to do substitution here, but you can. Du, what's the derivative of 3x plus 4? 3 dx. So when I do the antiderivative, 3x plus 4 is going to turn into u. All I have left though is a dx, so I don't need my 3. We would divide it over, so the dx portion gets replaced with a 1/3 du. Coefficients stay. What is the antiderivative of sine? Negative cosine, because the derivative of cosine is a negative sign. So this is negative 1/3 cosine u plus c. So at the end, replace the u, which is 3x plus 4. Do 5 and 6 and then stop. What is u? Is this one where I could get by without the substitution rule? No, because we have multiple x's. What is du? Okay. So when I integrate, the x squared will get replaced with my u, so that gives me a cosine of u. Do I need this too? No. We have an x and a dx. So those two things are what we have to replace. So we would have to divide our 2 over, so 1/2 du equals the x dx. Did I replace this 3 anywhere along the way? No, so it's just staying. So the 3 stayed, the x dx is a 1/2 du. So this turns into a 3/2 cosine of u du. What's the antiderivative of cosine? So this is 3/2 sine of u plus c. And so then at the end, you just have to get rid of the u, and u was. How would you know if you did these problems correctly? Do the derivative and see if you get back to your original.
So the du drops.
When you do an antiderivative, the integral and the du are together. So when one goes away, they both go away. Last one. What is my u? Du. squared plus 2, or x to the fourth plus 2, will turn into my u, so we get a cosine of u. X cubed dx is all I need, so I don't need my 4, so we have to divide that over. So the x cubed dx gets replaced with a 1/4 du. Antiderivative of cosine. And replace our u. So at this point, you need to finish your 5.4 homework. I'm going to take a look at 5.5, and I'll put up here the problems that you could start in case you get done with 5.4 and you want to start working on that. Okay? So 5.4 is due tomorrow. 5.5 we will keep working on tomorrow. If you have time and want to start the 5.5, you could probably do the 3 through 39 every other op.